weight of the chocolate chips in a 20-ounce bag of cookies is 13 ounces, then we could set this up as a problem. Weight of chips over weight of the sample, and sample being the bag of cookies. Okay, so we said the weight of the chips was 13 and the cookies was 20 ounces. So now we're down to a fraction, and a fraction is a division problem, and a division problem can represent a percentage. So get your calculators out. Right here, it's okay to keep the video rolling. Just let them get their calculators out, Miss Bryant. Okay, so I should see some people starting to do this problem. 13 divided by 20 should give you a decimal, and will give you what percent the cookie is of chocolate chips. So by now, most of you should have figured it out. I hope nobody's blurting out. But it comes up, and it's 0.65. And 0.65 times 100, because 100 represents the whole, or the percent, is their cookies are 65% chocolate chips. Okay, the next thing that you're looking at on page 40, and you're going to follow along when I read this out loud, is samples, right under the math message. And we're defining what a sample is. In math, a sample is not just something you taste, it's something we can do math with. So, a random sample is a sample that gives all members of the population the same chance of being selected. Next, you have another thing, which is a biased sample. It's a sample that does not truly represent the total population. A sample is biased when the method used to collect the sample allows some members of the population to have a greater chance of being selected for the sample than others. Okay, so look at the table that they're giving. Random sample. This is examples of some random samples. Heights of boys in the 6th grade class. Now look to the right. On this right side it says bias sample. Heights of boys on the basketball team. The heights of the boys on the basketball team is not, everybody's probably going to be what? They're going to be taller. So look at the next one. Random sample. Math scores of 6th grade. Next, on the right side, the comparison is math scores of students in a math club. Is that going to be a biased sample? Yes, because if you're in a math club, you like math, and you're probably going to have a higher score. Next one, batting average for an entire baseball team. Batting average for the starting lineup of a baseball team. Your starting lineup is going to be the people who are the best at hitting the ball and getting on base. Door prize for for 1 in every 10 people. Door prize for people who bought 5 or more tickets. So see how the right side, it changes and it adds a bias, whereas the left side is truly a sample. So, next thing you're going to do is for problems 1 through 3, tell whether you think the sample is random or biased. You cannot just write random, and you cannot write just biased. You have to explain why you think it's random or why you think it's biased. So at this point, you go back to the partners that I assigned earlier, and you complete 1, 2, and 3. You can pause the video.